Hey guys, thank you for logging on to my video. I'm going to try and make this fast for you. So we're going to go to 6.1. We're going to talk about systems of equations, and we're going to talk about solving them by graphing. So if you're watching this video before you take the Unit 5 test, this is still what you're going to be testing on. You will be graphing on your test. You will be solving for y on your test. So what we're going to do, is still practice. Our units build on each other. I felt comfortable starting with this and then taking your test next class. So with that said, let's highlight our learning targets. I can determine if an ordered pair is a solution to a system, and I can solve a system by graphing. So before I really get into anything else, I want to review and talk about what a system is. So this was in Unit 4. We talked about testing solutions. That's exactly what I'm about to do right now. Is the point -2, 4 a solution to the equation? Why or why not? So what we do is we plug in where x is, I plug in my x value. Where y is, I plug in my y value. And if I get 8 on this side, then I'm good. But if I get anything else other than 8, then not great, not a solution. So I simplify in my calculator and I get -12. And -12 does not equal 8. So it is not a solution. And we can say for a couple things, they're not equal. It's not a true statement. Or we can say a false statement. Okay, but we're going to be talking about that again today. So, let's talk about what a system is, because there is something a little bit different here. What is a system of equations? Well, it's a problem where we have more than one equation. So think about like what you call a group of sheep. You call that a herd. A group of fish is called a school. But when we have a group of equations, we call it a system. That's a very like coding word. The higher up you get in coding, you start using that same kind of language. So we have one specific thing though, more than one equation with the same solutions. So we have to make now 2 equations work at the same time. So how we do this is we plug in the y values and x values into both equations. And if they're both true, then we're good. But if either one is not true, then it's false. So let's try it out. 3 times x, well, instead of x, I'm going to put 0 because that's my x value. Minus 7 times -4, because that's my y value, so I'm going to plug that in for y, equals 28. And then I go into my calculator and I plug this whole piece in. 3 times 0 is 0. -7 times -4 is positive 28. So I'm good. But I need to do that one more time because in a system they both have to work. So y equals 9x minus 4. Y is going to be -4 equals 9 times, or parentheses, times 0 minus 4. 9 times 0 is 0, and I'm left with -4 equals -4, and that's perfect. Because they are both true, then the ordered pair is a solution. But if either equation is false, then the ordered pair is not. So if the bottom one had equaled 0 instead of -4, then it wouldn't have worked. Now what the bulk of your homework is going to be is solving a system by graphing. So you have 2 equations now instead of just one that you're graphing, but everything else is pretty much the same. So step 1 is graph both equations. Let's talk about our equations because this one's in the form y equals mx plus b. Really easy to graph. We just look at it. You've been doing this since 8th grade, the whole shebang. But this is newer. We did do this year. So there's 2 ways you can decide you want to graph this equation. The first way is make it into y equals mx plus b and then graph. Or you can graph using intercepts. So you can find the intercepts, x and y, and then plot those. So those are your 2 options, and I'm going to show you both. I've got 2 things. So on this one, I'm going to show you by turning it into y equals mx plus b. And this one I'm going to show you by graphing with the intercepts. Okay, and then we'll talk about the system part. That's step 2. So let's graph the first one. I'm going to use my intercepts, so that's using the cover up method. So I'm going to cover up one of them and then solve for the other. So negative 2y equals 6. Divide by negative 2 on both sides. Y equals negative 3. And then I go over here and I cover up the other one. X is already by itself. That's really cool. So x equals 6. That's graphing using the intercepts. That's our cover-up method. We have gone over the actual math of that before. If you need help, wait till I'm back and we'll talk about it more. Okay, but that's using the intercepts. What I do at this point is I go to my graph and I say, okay, x equals 6. So there's a dot on 6. Y equals negative 3. Dot on negative 3. And it's best to use a ruler, but, you know, do your best freehand. It's all good. Go, kind of like that. Awesome. And then I graph the other one separately. I'm going to switch colors. If you have different colored pencils, that would be awesome too. So I plot my y-intercept first, which is 3, the number without the x. And then I am going to count my slope. My slope is negative 1/2. So down 1 over 2, down 1 over 2, and there we go. Connect your dots. And there's my system graphed. So I have 2 equations on the same line. That's what it means to have a system. Step 2 is what you actually plug into Delta Math. So now that I have 2 equations, I am looking for where both of them have a solution. I'm looking for the solution, which is where they cross. Think of it as like X marks the spot. So my solution for this problem is going to be that point right there where they both crossed, and that is parentheses 6, 0. Okay, that's my answer. That's what I plug into Delta Math. So on your problems on Delta Math, you will have to graph them and then state where they cross. And that's how it's done. That's with graphing the intercepts, graphing using the intercepts, sorry. Now I'm going to show you graphing using solving for y. So we'll graph the first one while we're here. That's in y equals mx plus b, which is nice. That means I don't have to do any extra mini math. I'm going to plot my y-intercept, which is 6, and then count my slope, which is 1 over 5. 1 over 5. Okay, use a ruler or something and connect your dots. Eesh, that was rough. It's okay. Kind of like that. But now this one is in standard form. And so you can either graph using the intercepts or you can graph by solving for y. So it depends on what you are most comfortable with in the last unit. I suggest this being your go-to. I know it's more math, but it is consistent. It will work every time. So minus the x term, divide the y term, simplify. 5 over 5 is 1. Negative 4 over 5 becomes negative 4 over 5x. So my y-intercept is positive 1. I'm going to switch colors now. My y-intercept is positive 1. And my slope is negative 4 over 5. So down 4 over 5. And I'm going to go the other way too because I think that's going to reveal my answer. Yep, there it is. So I connect my dots. And I see my X marks the spot. So that's my answer. And that is at X value first, negative 5. Y value next, positive 5. That is my answer. Okay, that is your homework today, and that's as hard as it gets. So try it out. Email me if you have any questions, and we'll talk about it when I come back and we really start Unit 6. Okay, have a good day.